Okay, so if you have any problems regarding that chapter, you can ask me. Okay, and this will be the third chapter, which is the curvilinear motion. So curvilinear motion also will be covered in your test one. Okay. All right. So this is the third chapter. For the slide, I'm not upload yet. So I will upload this slide in the e-learnings after this class. So previously you learned on rectilinear motion, means that it's on a straight line.
Question. If you could, can I scan the appendix?
Okay.
Little bit.
Previously we learned on rectilinear motion, which is the straight line. Okay, so straight line. And for this chapter, you learn on a curvilinear motion, means that on a curve line. Okay, so you need to able to differentiate between a rectilinear motion, which is a straight line motion, and a curvilinear motion. So in a curvilinear motion, you have several analysis involved. Okay, because due to the curvilinear shape of motion, so you will have an extra and additional parameters uh, that you need to find. Okay. Okay, so for the plane of curvilinear motion, so we deal with is a two dimension. Okay, two dimensional. So you have a plane x and y. Okay, so and the most important thing here is when your particles, okay, when your particles move in a curvilinear motion, in a curvilinear path, you need to know how to find or how to determine the velocity. Okay, and in order to determine the velocity, velocity must always be tangent to the curvature and in the direction of motion. Okay, so velocity always follow the direction of motion and tangent to the curve. Okay, let's say you have the curve like this. Okay, so at this point, let's say I put here as point A, the velocity should be tangent. Tangent means tangent to the curve. So this is your V, velocity. So let's say you are at point B. So your velocity direction should be tangent to the curve. Okay, let's say you are at point C. So this point C. So velocity tangent to the curve. Okay. So means that the velocity direction will change according to the curve, according to the shape of the curve. Okay, so this is your V. Alright, so this is the important things that you need to know. So velocity always tangent to the curve and follow the direction of the motion. Okay, this is one parameter that you need to understand, the direction and also how to determine the direction with the curve. Okay, and then the second thing, if you have a velocity, you will have sometimes you will have an acceleration. So a component of acceleration must always inwards of the curvature. Okay, so velocity tangent to the curve, acceleration inwards of the curvature. Okay, so let's say this would be your, it should be, so this is the curve. Okay, this is your curve. And then the acceleration at point C should be always inward, either this direction, or this direction. So this can be your acceleration. So at point A, either here or here. So it should be inward, okay? Inwards to the curve, okay? So this is the direction of acceleration. Okay, as you may notice in this path here, the red line represent the velocity. Velocity always tangent to the curve, and then the blue line represent the acceleration. So you have this curve, like this, and then acceleration should be inward to the curve. So the curve like this, and should be inward. Okay, so for this point like this, so it should be inward. Okay, and for this curve, it should be inward to the curve. Okay, so any question? Any question so far? So this is very important. You need to know where is the direction of velocity, and then you need to know the acceleration must always inwards of the curvature. Okay. So if you know this one, this is you will able to do the analysis properly. Okay. Sometimes as I notice, students pull like yes.
What type of graph is this?
This is not a graph. This is just to determines the direction of velocity and acceleration. Okay, when you do the analysis of a projectile motion, you need to know how to determine the acceleration and velocity. For this chapter, we are not dealing with a graph like a previous chapter. Okay, you need to know how to determine this velocity and also this acceleration at a certain position. Okay, so all right. So in this chapter, you have three type of analysis that can be done when we have a projectile motion or a curvilinear motion. Okay. So the first method is a rectangular coordinates, which is you use the axis x and y axis with respect to the reference point at the origin. Okay, so let's say when you throw something from point A to point B, you throw the ball from point A to point B. So means that you have a reference point, which means that from point A to point B. Point A will be your reference point. So you will measure what is the distance, what is the velocity at A, and what is the velocity at B. So this is the parameter that you need to determine, and that based on reference point. So this is rectangular coordinates x and y. And then you will have other methods that call normal or tangential coordinate. So for normal and tangential coordinate, we will do specifically on the particles. Okay, there is no reference point. So the analysis involved on the particle itself. Okay, for these rectangular coordinates, this is our particle, so we will refer to, let's say for this example, we refer to the origin. Sometimes in real case, we will refer to the initial point, let's say from point A to point B. So our reference point will become our point A. So this is for rectangular coordinates. But for the normal and tangential coordinate, we will do the analysis on the particle itself at the particular position. Okay, at the particular position, you need to do the analysis. Okay, means that you need to determine the normals and the tangential, normal and the tangential uh, parameter. Okay, like I mentioned previously, in a tangential, you have velocity. In a normal, you will have acceleration. Okay, acceleration in normal. So if you notice here, normal normal always inwards to the curvature. Okay, normal always inward to the curvature. Okay, so this is normal. So it's always inward. This is your curve. So normal always inward to the curvature, and then you will have a tangent to the curvature. So you have two axes, normal and tangent, and this axis is located on the particles. Okay, this axis is located on the particles. And then let's say at point B, this is your tangent, this is your normal. Normal always inwards. Okay, tangent follow the motion direction. Okay, and then at the particular point at particular position C, you will have normal inward to the curvature, and then you will have tangent. Okay, so along tangent and normal, actually you will have acceleration. Okay, so you need to determine what would be the the total acceleration based on acceleration normal and acceleration tangent. So I will discuss more after this. Okay. So then the third analysis, you will have polar coordinates. Okay, polar coordinates. So for polar coordinates, we will still have a reference point. So for this case, origin will be our reference point. In a certain case, let's say you look some car is moving, okay, around the curve. So you are sitting on a certain point and the car is moving at a certain point. So the reference point is you. Okay, so when you want to measure the r or theta, then you need to have a reference point. Okay, so for this example, origin will be your reference point. So okay, so for the polar coordinate, you will have a parameter of r, and then you will have a parameter of theta. Okay, so this theta and r will represent the positive and negative direction. Okay, so for r, okay, this axis always outward from this r. Okay, always outwards from this r. So this is the positive direction. So please remember, when we deal with velocity, when we deal with acceleration, this is a vector parameter. So you will have magnitudes and direction. So that's why the direction is important. Okay, so for this r polar coordinate, you need to draw r and theta axis based on this reference point. Okay, you draw the r and theta axis on the particle, but in order to draw this r and theta, you should refer to this reference point. Okay, so for r is always outward from this r. So usually in the question or in the problems, it will provide you what would be the r from the reference point to the particles. So you know that this will be your r, and then you just draw the outward line to represent the axis of the r, the positive axis, always outwards from the particle. Okay, and then for the next axis is theta. So how to determine this theta is based on this direction. Okay, for this case, the theta is on this direction, so the positive theta axis should follow the same direction, this direction. Okay, so this is positive theta axis. So any parameter that follows this theta axis will become positive. Okay, so let's say, for example, you are given with the problems or question, the theta like this. It gives you the theta from the y axis like this. So in order to draw the theta axis, the positive theta axis will become like this. This is your positive theta axis based on this direction. Okay, so when you want to draw the theta axis, please refer to the direction of the angle at the reference point. Okay, so then since we have three methods or three systems, so which analysis approach or coordinate system is suitable? So it depends. Okay, depends to the form in which the data is specified. Okay, so when you want to do the analysis, you read on the information, what the information that you have. Okay, and then depends on the manner which the motion is generated. Okay, so usually when we want to do the analysis, the information given will provide you which method that you need to use. Okay, because on each method there is a specific parameter that you need to determine. Okay, so that's why from that information you directly know that which method that you need to use. Okay, so this is the combination analysis is actually, so in one analysis sometimes we can combine the problem either from the rectangular coordinates with a normal and tangential coordinate. So in one problem you will have two analysis that you need to do, or it can be a combination of rectangular with polar coordinates. It can be a combination from normal and tangential coordinate with polar coordinate. So it can be a combination. So in one analysis, sometimes you need to do two or three. analysis together. Okay, so in a rectilinear motion, you are learning that velocity is a rate of change of displacement. Okay, rate of change of displacement, which is ds over dt, and acceleration is a rate of change of velocity, which is dv over dt. Okay, so we still do these things. We still refer to this displacement, velocity, and acceleration. Okay, so the concept is still the same. Okay, and then if we refer to this example, this is your particles at this position. So in these particles, you can do x and y analysis. Okay, so x and y analysis. So x and y analysis, you have the own equation. NT analysis, we have another equation, and also R theta analysis, you have another equation. So each specific method will have their own equations that you need to understand and remember. Okay. So if you notice here on theta and r, so since the direction of theta is into this direction, so the axis of theta is following the direction of this angle. So this is your r. So in order to draw the axis r, just outward from the particles. Okay. So for the NT analysis, at this position, so this is your curve. So tangent to the curve is your T, and inward to the curve is your N. So please remember that. Okay. So that's it. This is to determine which is the direction and how to draw the axis. Okay, at the certain position of the particles. Okay. So this is we go first on XY analysis. Okay, so for SY analysis, the typical problem is a projectile. Sometimes when we throw a ball from reference point A to point B, so this we call this is a projectile. So as I mentioned previously, SY analysis we will have equation along X and equation along Y axis. Okay, I believe if you look at this equation, most of you are familiar with this equation. You are learning that this equation in previously in your secondary school. Okay, so for the projectile problems or SY analysis, normally only gravitational acceleration g is considered. Okay, for the acceleration we only consider as gravitational acceleration. Okay, so please remember that. So g is a constant acceleration along y axis. This is the value of acceleration or g. Okay, meaning that on this particular equation y axis, this ay here is equal to g. Okay, and then independent analysis of for x and y axis, solution for both axes are related through time. Okay, what we can relate from y and x axis is that the time. Okay, the time taken along y and x should be the same. Okay, so when you want to do the analysis, if you want to relate, okay, the motion of the particles, okay, you can relate y and x axis in terms of its time. So you can relate this equation together. Okay, sometimes you need to use this equation in order to determine the parameter. Let's say the displacement, velocity. Okay. All right. So I will explain why we have only acceleration along y. Okay. Why we don't have the acceleration along x. So I will discuss after this. Okay. So this is the displacement and time relationship. Okay, so when you have a projectile, let's say you throw a ball from point A to point G. Okay, so this is the shape of the motion or the path. Okay, the shape of the path for the ball when we throw. Okay, so basically we will have a relationship here. Okay, So this is the observation. As the projectile move up, the y component of velocity will decrease, okay, in magnitude. So meaning that if you notice, initially the velocity along y is higher compared to the point B velocity. So velocity at point A along y will be higher to the velocity at point B along y. Okay, and same goes to velocity at point C along y. So this is the relationship. Okay, VAY more than VBY more than VCY until it stops momentarily before changing the direction. As you already learned in rectilinear motion, when there is a change in direction, the velocity will become zero. So at this point D here, there is a change of direction. So V dy will become zero. Okay, meaning that the velocity along y direction. Okay, so as the projectile starts its motion downwards, the y component of velocity will increase in magnitude. Okay, so meaning that VEY uh, less than VFY and less than VGY. Okay, means that it will increase. Okay, from VEY it will increase to VFY and it will increase to VGY. Okay, so what the relationship that we can get here? Okay, the third point here, which means that the y component of velocity is equal in magnitude, not direction, when the projectile is at the same level of height. Okay, what is meant here? At point A and point G, there is a same of height. So VAY will be equal to VGY. The magnitude, okay, not the direction. Okay, as mentioned here, the magnitude of VAY will be equal to the magnitude of VGY. Okay, that's why it put here in a modulus VAY equal to modulus VGY, because we just want the magnitude. The magnitude is the same, okay, but not the direction. So at this position, the velocity of VBY and the velocity of VFY is the same. Okay, the magnitude. Okay, same goes to VCY and VEY. The magnitude is the same. Okay. All right. So here is you may notice that the velocity VCY and VEY is the same. Okay, the direction is different, and the time here is also different. Okay, the time here is also different. So there is a relationship that you can make here. Uh, at the same height, there is a difference in time between 2 points, but same in direction, but same in velocity magnitude. Okay, you need this information during the when doing the analysis. Okay, let's say at this height you have same velocity magnitude but different time, but with different time, with different time. Okay, so this information is needed after this. Okay, when doing the analysis, you will understand why I mentioned that at this height you have different time between 2 points but the same magnitude of velocity. Okay. Okay, so the y component of velocity is equal to 0 at its maximum height. So this is another important terms here. At the maximum height, velocity along y is 0. Okay, at the maximum height, the velocity along y is 0. Okay, so vy equal to 0, maximum height. Okay, sometimes in the question is asked you, please determine the maximum height of the particle at that point. So you know that the information that you have, okay, maximum height, Vy 0. Okay, V along Y will be 0. Okay, so along Y, so this is along Y. So the only acceleration, unless stated otherwise, acting on projectile is A equal to G equal to 9.81 acting downwards. Okay, so since acceleration is a vector, so we need to consider the direction. So downwards means that when you use acceleration, it's always negative 9.81 meter per second squared because the direction is downwards. Okay, so don't forget to put the negative. Okay. So then we go on the observation of along x. So this one is observation along y-axis. This one is observation along x-axis, where we assume to the right is positive. Along y, upward is positive. So that's why uh, g downward it become negative. Alright, so when we go along along x, you will notice that VAX, VBX, VCX, VDX, VEX, VFX, and VGX is the same. Okay, you may notice that the velocity along x always the same from the start to the end. Okay, so that's why since the velocity along x is constant throughout the flight, okay, throughout the projectile motion, the velocity is constant. So that's why acceleration along x is 0. Okay, if you refer to this axis, there is no acceleration along x axis because we assume that throughout the projectile motion, uh, the acceleration, the velocity is constant. Okay, so you don't have that's why you don't have acceleration along x axis. Okay, so the acceleration acting on projectile is only acting downward. Okay, so ax is equal to 0. This means that the horizontal component of the velocity vx is always assumed to be constant throughout the flight. Okay, so this is the information that you need when you deal with projectile motion. Okay, when you deal with projectile motion, this is the information that you need to understand lah. Okay, so any questions so far? Ada soalan ke?
No question,
Okay.
sir.
No question, eh? So please remember the important terms here lah. For projectile motion, what would be the important terms that you need to remember lah? Okay, because it will help you to solve the problems. Okay, when it's a maximum height, what will happen? V1 is 0. Along x-axis, the velocity will be constant. Okay, so along the same height, the magnitude of velocity is the same. Okay, but the direction will be different and also the time. Okay. All right, so then we go on. Okay, so this is the why I mentioned that at the same level, you have same magnitude velocity but different in time. Okay, so this is the implication of time values. Okay, you have the first diagram and also the second diagram. So we go on the first diagram first. Okay, a particle is launched from A. Okay, so this is the start point. So like I mentioned, this is your reference point. Okay, for SY analysis. So A will be your initial point. So you may notice that uh, okay, in this analysis here, you have a quadratic equation which means that t squared here. So here you have t squared. So when you want to find the time using this kind of equation, you will notice that you will get t1 and t2. Okay, you will get t1 and t2 due to the quadratic equation. Okay, so the implication from that equation is that there is two possibilities. You will get both time positive, or you will get either one positive or one negative. So the implication is here. Okay, so the first point here, when you solve that quadratic equation, you will get that the values, the time, both time is positive, means that what it means when both time is positive, both time are on the same level measured from the datum. Okay, meaning that when you use that quadratic equation, you will get two times. So the lowest time will be point B and the highest time will be point C. Okay, why do you get a positive value? Since both point B and point C is above point A. So that's why you get positive value for both time. Right? The smallest time is for B and the highest time is for C. Okay, like I mentioned, why? Because in this equation, you may notice that we can relate the velocity. So as I mentioned, velocity is the same. On the same level, the magnitude is the same, but the time is different. So in order to determine the time, so you just notice that for the smallest time, B, the highest time is C. Okay, so for the case of both time is positive. Okay, and for the second diagram here, for the second diagram, where you will obtain the time positive and negative. One time is positive, one time is negative. So what is mean here? It means that let's say a particle is launched from point A. So this is the starting point, your reference point, point A. So what it means when you get negative and positive? So negative means that B is below the datum. So means that the negative point is referred to this point B. And the positive time is referred to point C. So it's actually, we will choose the correct point, which is point C, the positive time only. Okay, we just choose the positive time only, which is point C. Because when we throw the ball or when the projectile motion occur, we will throw forward. Okay, we will measure the time forward. So that's why you choose a positive time, which is the correct location is actually point C. Okay, we don't take a negative time. Okay, so you will notice that when you do the analysis. Okay, either you want to choose the time, which time that you need to choose, either it is negative or positive. It depends on the location of the reference point. Okay, either is above the datums or below the datums. Right, so then after we finish the XY analysis, so we go on NT analysis. So if you notice that the difference between SY analysis with NT analysis is that NT analysis is, we do the analysis on that particle. Okay, we don't refer any reference point. Okay, we just do it on that particle. Okay, so NT is origin is located at that particle, no reference point, and then T axis is tangent to the curve. That's why we put T. T means tangent to the curve along the direction of motion or velocity direction. Okay, and then N axis, N refer to normal axis. Normal axis always inwards of the curvature. If you have the curve like this, then this is your N. If you have the curve like this is your N. Okay, always inward. Okay, if you have the curve like this is your N. This is your T. Okay, this is your T. This is your T. T follow the direction of motion. Okay, it depends. Usually, it will provide you where is the direction of the motion. Okay. All right. So when you have a normal and tangential axis, then you can find the velocity tangent and velocity normal, and then you will have acceleration tangent and acceleration normal. Please bear in mind, velocity and acceleration is a vector. So when you want to find the total, let's say the total velocity here, you cannot directly add the magnitude together. You cannot do that. Okay, this is vector. That's why we have arrow here. Okay, let's say if you want to determine this velocity, so it should be in terms of vt squared plus vn squared, like this. So for acceleration, it should be at squared plus en squared because it's a vector. Okay. So for velocity, we have only velocity to tangent. Okay, we don't have a velocity to normal. Okay, because it follow the direction of motion. Okay, the direction of motion always tangent to the curve. Okay, And then for the acceleration, we have acceleration to tangent is related to this v. Okay, is related to this v. Okay, vt. So we know that acceleration is dv over dt. So we can put in terms of v dot, the rate of change of velocity in dot. Okay, so at is dv dt. Okay, you can get at referring to this v by referring to the vt. Let's say, for example, sometimes it's mentioned that the velocity is constant. So you know when the velocity is constant, at will be 0. Okay, acceleration will be 0 because this at is related to this velocity. And then if you have then you have another acceleration that related to the normal. Okay, that related to the normal axis, which is acceleration normal acceleration. Okay, and this normal acceleration is related to v also, but is with the radius of curvature. So because normal is referring to the curvature shape, is always inward, so you need to consider the radius of curvature and also the this velocity. Okay, so you know that this velocity is meter per second. Okay, velocity is meter per second. So if velocity squared, you will have meter squared per second squared. So this is the unit, meter squared per second squared. So since here is meter squared per second squared, meter squared per second squared over radius of curvature, which means that the radius is equal to meter, okay, in unit meter. So meter squared per second squared per meter, then you can cancel out this meter and this square. So you will get meter per second squared, which is the unit of acceleration. So usually you can check or either it makes sense or not. So you can check it in terms of its unit. So here you get the unit is meter per second squared. Okay. So this is for anti-analysis. So this is the derivation of why we get v squared over r here for acceleration to normal. So basically, it's based on the arc analysis. So you know that when we do when the particle move in a curved shape or in a curved path, so it's just like our arc. Okay, it's just like the arc here, the length of this arc. So the length of this arc can be determined based on s equal to r theta. S is the length of the arc, r is the radius, theta is the angle between the radius. Okay, so s is equal to r theta. Okay, and the change s is the distance, is actually the length or the distance of this arc. Okay, as I mentioned, if you differentiate displacement with respect to time, you will get velocity. So this is your displacement s. Okay, this length here, this is your displacement. So ds over dt, you substitute s with r theta, you get r d theta over dt. Okay, d theta over dt. So d theta is the change of angle, the rate of change of angle. Okay, the rate of change of displacement, you will get velocity. Okay, in a straight line motion, let's say from point A to point B, A to B, you have the displacement. Okay, the distance. So the rate of change of displacement, you will get velocity. This is a rectilinear motion. Okay, so for the curve, you have the displacement is r theta, s equal to r theta with respect to radius and theta, because you have a curve shape. So in order to get the velocity, you need to differentiate ds over dt. Okay, so means that the changing here is only theta. Okay, r is constant. Okay, if you move in a curve, r always constant. Okay, but the change only the theta value. So that's why here we have r d theta over dt. So d theta over dt is equal to omega. Okay, what is omega? Omega is actually angular velocity. Okay, omega is angular velocity. V is a rectilinear velocity or the straight line velocity, and the omega is a angular velocity. So then you get V is equal to R omega. Okay, so this is the relationship when you're moving in a curve. The rectilinear velocity can be determined using R and angular velocity. Okay, so you will notice that on the next chapter you will face this symbol, which is angular velocity. When the, let's say, when the system in motion, you learn on the moment. Okay, you learn on, previously you learn on the moment, on the rotation. So in a static class, we don't consider omega, because in a static class the system is not in motion, the system is static, so there is no velocity. But for this dynamics, we consider that the system is in motion. So when you want to find a summation of force, then you need to include this omega, so this angular velocity. So you will notice this omega on the next chapter. Okay, so if we then we know that acceleration is equal to dv over dt. Okay, so this is relationship between displacement and time to get velocity. This is relationship between velocity and time to get acceleration. So we know that v here for the curvilinear motion is based on v equal to r omega. So if we change with a equal to let's say I choose this dv dt. So dv dt is actually dv dt v theta. Okay, so v equal to dv dt over d theta. Okay, so you can refer to this if you notice here, in order to get this here s equal to r time with theta. So you get is equal to r theta, and then you differentiate ds with respect to dt, then you get this r omega. Okay, for this case we have here is v and d theta. So in order to get dv is equal to v d theta. So it's actually seems like this relationship. Okay, so then we know that A is equal to dv over dt. Okay, then we substitute dv, this v d theta into this equation. So we have A equal to d theta over dt. Okay, so d theta over dt is actually, d theta over dt is actually this omega. Okay, so A is equal to v omega. Okay, so this is the relationship that you obtain, v equal to v omega. So v omega here, so you have v equal to r omega. So omega is equal to v over r. Okay, so you just substitute w into this equation, then you get A is equal to v times with v over r. That's why you get this kind of equation, v squared over r. Okay, this is the equation of acceleration to normal. Okay, so you can refer to this kind of slide lah, to this slide for the how to get the v squared over r. Okay, the derivation. Okay, the derivation of velocity and acceleration when the particle move in a curvilinear motion. Okay, but the derivation is not included in your test. Okay, you just need to remember the equation, vt equal to v, vn equal to 0, at equal to dv over dt, and n equal to v squared over r. So in equation, you need, in a question or problems, you need to understand this equation only. Okay, I just provide the extra knowledge to all of you on how to get the acceleration. Okay, when the particle move in a curvilinear motion. Okay, so we have here is example when the particle is moving from point A to point B. Okay, so this is point A and it's moved to point B. So if you notice that there is a speed increasing and speed decreasing. Okay, when the speed is increasing, you may notice that this is you know the gray always V because V always tangent to the curve. Okay, V always tangent to the curve. Okay, V and then this V. So you may notice that the acceleration is on a green line. If it prefer to the direction of motion, then is speed increasing. Okay, if you notice the acceleration is on almost the same to direction of motion, then the speed is increasing. But then you need to understand acceleration always inwards to the curve. Okay, acceleration always inward to the curve. Okay, for the speed decreasing, you have A to B. This is the direction of motion, V. Okay, direction of motion. And you may notice that the acceleration or in opposite, prefer to opposite direction of the direction of motion. So we can say that the speed is decreasing. Okay, or deceleration. Okay, decreasing. Okay, any question? Ada soalan ke? Any question?
No.
No, Doctor.
Okay, so this is for NT analysis. So in NT analysis, you need to understand the direction of N, the direction of T, okay, on the particle. So please remember, NT analysis is done on the particles, okay. All right. So this is the next analysis, which is the third analysis, R theta analysis. Okay. For R theta analysis, we need to have a reference point. Okay, we need to have a reference point. Let's say for this example, for this slide, in this slide, we have origin. So when you want to draw this axis r and theta, you need to refer to the reference point. For this case, is origin. Let's say when you're watching a bird, okay, moving in the sky, okay, flying in the sky. So you yourself are the reference point, and you looking to the bird. So the distance from you to the bird is your r, okay, and the motion of the bird is based on this theta direction. Okay, if you look from x to this r, then your positive axis should be this direction, and the positive axis for r should always be outward from this point. Okay, sentiasa terkeluar daripada particle. Okay, for positive direction. So for R and theta analysis, you will have another parameters. So V theta, VR, A theta, AR. Okay, that need to be fine. Okay. So as I mentioned previously, if you have the theta is given in like this, so means that this should be the direction. So the positive theta axis should be this direction. Okay, so please make sure when you draw the axis, please follow the correct direction because it will represent the positive and negative direction of the velocity and acceleration. Alright, so this is the equation that you need to remember for R theta analysis. Okay, so R theta axis is origin. Origin is located somewhere from the particle. Okay, and R axis from origin in radial direction to the particle, and then theta normal to R axis, positive along positive theta. So what is meant by normal to R axis is that R and theta always perpendicular. Okay, N and T axis always perpendicular, 90 degree. X and Y axis always perpendicular, which is 90 degree. Okay, so then for velocity, you can determine the velocity of the particle by using VR plus V theta. So please remember, this is a vector. You cannot add up directly. Okay, you need to use a vector analysis. Okay, so VR squared plus V theta squared square root, then you will get a V. So let's same goes to acceleration. So acceleration can be found using AR plus with A theta. Okay, AR squared plus A theta squared square root, then you will get the A, the total acceleration. Okay, so VR is equal to R dot, V theta is equal to R theta dot. Okay, and then AR is equal to R double dot minus R theta dot squared. A theta is equal to R double theta dot plus 2R dot theta dot. So you just need to remember this kind of equation. So usually from now, I believe you still blur. Why do we need this equation? So usually in the problems, you require to determine this parameter R dot, theta dot, R double dot, and theta double dot. So you need to determine this parameter. Usually in the problems, you need to determine this parameter. So VR, V theta, AR, and A theta can be determined using the given acceleration. So you means that you need to resolve. Given with the acceleration at a certain angle, you resolve that acceleration. Resolve acceleration to R axis, resolve acceleration to theta axis. Okay, and then from the given AR and theta, then you can determine this parameter. Okay, usually the question like that. Okay, so that's all for the information for this chapter. So then we can do on the examples and exercises. So for now, any question? Ada soalan ke?
No.
Okay, if you don't have any question, I think we take a break around 5 minutes. Okay, so that you can look back to the previous question. Okay, to previous equation and previous information. Okay, before we do the example exercise. Okay, so uh, we will continue at 12:02. Okay, 12:02. We will continue by doing the example and exercise. So you can take a break around 5 minutes. Okay, so for those who not yet scan your attendance, please scan it now. So guys, let's continue to the first example. Okay, so are you there?
Yes, doctor.
Okay. So we have example 3.1. So for those who have the book, you can refer to this example. So as I mentioned, I hope everyone can buy the books so that you can do the revision, okay, properly. All right. So this is example 3.1. We have a projectile. A projectile is launched from A with an initial velocity VA is equal to 10 meter per second as shown determine. As shown. So determine the horizontal distance D, okay, given here the horizontal distance D, and then the maximum height H max. Okay, before we do this example, let me explain to you the equation. So V represent V is actually represent the final velocity. Okay, final velocity. Okay, U represent initial velocity. Okay, and then AY is actually G and T is time. Okay, so SY means that final displacement along Y, and then S naught Y represent initial displacement along Y. Okay, along Y. All right, so this is the information that you need to know. So Uy is initial velocity along Y, Vy is final velocity along Y. So T is time. Okay, along X, the information that you need to know is final velocity displacement along X, and then S naught X is actually initial displacement along X. Okay, along X. Okay, so we have here is two question, horizontal distance and also the maximum height. So I mentioned previously, if we have maximum height, what will be the information that you have? Maximum height?
Velocity 0, sir.
Yes, correct. Your velocity at maximum height here, so means that velocity at this point is 0. So I put here as VB lah, VB equal to 0. So this is the information that you have. All right, so first we go on horizontal distance. When we talking about horizontal, means that we deal with you need to use x-axis, okay, because horizontal x-axis. So in order to use x-axis, the only equation that available to you is sx minus s naught x equal to uxt. So let's see if I put here is sx minus s naught x equal to uxt. So this is the equation that you can use to determine the horizontal distance because it represent displacement here. Okay, for this case, just Vx is equal to Ux. Okay, initial velocity is equal to final velocity along X component. So, in order to use this equation, you need to determine what is the parameter that is available or the parameter that is known to all of you. Okay, so first, we have here, this is our point A, and then this is our point C. So the start point or the initial point is point A. Okay, point A is the initial point. Point A, initial point. Okay, why do you need this initial point? Because you need to determine uh, UY. You need to determine S naught Y. Okay, so this is for initial point. So UY, what is UY? Velocity along Y. So you are given with a velocity with the angle 60 degree from the horizontal component. So means that you need to resolve this force. You need to resolve this velocity. Okay, so here is your X, here is your Y. So uy is 10 sine 60 meter per second, because it's a positive direction upwards, so positive, uy is positive. Okay, so s naught y is 1.5. Okay, 1.5 meter. S naught y is 1.5 meter. So from the datum here, okay, from the datum. So this one is for y component, and then we go on x component. So you have ux is 10 cos 60, and the direction is to the right, which is positive. So 10 cos 50 meter per second, and based on this analysis, ux is equal to vx. So ux equal to vx. So throughout the flight, okay, throughout the projectile motion, the velocity is the same, which is 10 cos 60. Okay, and then you need to determine the s naught x. So s naught x, so reference point A here, so we don't have any datum for this point A, so we just assume that this point A is the initial point along the horizontal component, so we just put here s naught x is as 0. Okay, to the starting point. So now this is all the information that you have. Okay, this is all the information that you have in order to determine what would be the horizontal distance between point A to point C. Okay, between point A to point C. So one more thing here. So point C is here. Okay, so means that you will have SX. So SX is from point A to point C. So your SX is T. Okay, and then S naught Y is 1.5, and then you will have SY. So SY is the final displacement along Y, so which is 5 meter. Okay, given here. So this is the final displacement along Y, 5 meter, and this is the initial displacement along Y, 1.5 meter. Okay, so this is all the parameter that you have. Okay, let's say I make it so point A initial point, so I have point C endpoint. Okay, endpoint. So point C, I have SY 5 meter, and then I have SX D meter. So okay, right. So I have initial point and I have the final or end point. Okay, so then if you look at this equation, okay, in order to get what would be this sx or this d, okay, you need to have s naught x. So s naught x is 0. Then you have ux. So ux is 10 cos 60, but you don't have time. Okay, you don't have time, so you cannot use this equation directly because you lack of one parameter, which is time. Okay, so how to get the time? As I mentioned previously, we can relate y-axis and x-axis with respect to its time. So the time between y and x-axis is the same. So in order to get this time, what you can do, you try to use any equation here of y-axis. So you have 3 equations. So you need to choose the equation that have enough information to solve. Okay, means that with this kind of equation, information that you have, you need to feed it in this equation. So you need to choose which equation that can be used. Okay, which equation that you can be used. All right. So if we go on the first equation, so the first equation you have, this is the first equation on y. So you have vy, uy, ay, and t. Okay, vy. So if you look at on this information here, there is no final velocity. So you don't have the information of final velocity, meaning that you cannot use this equation, because you only know uy and ay. So t,
嗯
uy is 10 cos 60. So you have to use this equation. So you need to choose which equation that can be used. Okay, which equation that can be used. All right. So if we go on the first equation, so the first equation, you have, this is the first equation on y. So you have vy, uy, ay, and t. Okay, vy. So if you look at on this information here, there is no final velocity. So you don't have the information of final velocity, meaning that you cannot use this equation because you only know uy and ay. So t you don't know, Vy you don't know. So you cannot use this equation. Same goes for, so for this second equation, you cannot use y because you don't have a terms t in this equation. You need t in order to fit into this equation. So second equation of y exists no t, no time, so you cannot use that. So the only available equation that you left here is just this equation. Okay, just this equation. Okay, so let me increase the space. Okay, so this is only the equation that available to you because you know sy, you know s naught y, and then you have the information of uyt, and then you have the information of acceleration on y. The only unknown here is just time. Okay, so this is the only unknowns that uh, have in this equation. So means that you can solve. You can solve this equation in order to get the time. Okay. So let me write the equation sy minus s naught y is equal to uyt plus half a t squared. Okay, so this is ay. So ay half a t squared. So sy minus 1. Okay, so what would be your sy? Sy is 5. S naught y is 1.5. Okay, equal to Uy is 10 sine 60, 10 sine 60 t. Okay, plus with half. Ay is actually g. So as I mentioned, since g is direction downward, so negative 9.81. So negative 9.81 t squared. Okay, so this is the equation. Okay, so this is the equation that you need to use, that you need to determine. So you have here is 3.5 equal to 10 sine 60t, plus here is a negative 4.905 t squared. So you rearrange this equation, you will get 4.905 t squared minus 10 sine 60 t plus with 3.5 equal to 0. So you have this quadratic equation, then you can determine the time t1 and t2. Okay, all right. So if I can, let me, okay, let me copy the solution from the books first. Okay, so that for those who not familiar with quadratic equation, you can refer to this solution lah. For those who know how to use the calculator, then you can use calculator. You will directly get times. Okay, you click the modes and then you click the equation and then you click 2 degree. Okay, so based on the calculator, you can directly obtain the time. Okay, so as from the books, it use this solution. Okay, so you rearrange the equation. Okay, and then you put it in this equation. Okay, you will get the time 0.63 and 1.14. So here is 0.63 and you get 1.14 second. So you got two positive value for the time. Okay, so the question asks the horizontal distance means that the distance at point C. Okay, the distance at point C. From point A to point C, the distance. So my question, why in the book they choose 1.14 second? Anyone want to try? Why they choose 1.14 second?
Because it time at sea, say. I don't think.
Because the time at sea. So 0.63, where is the location? Where
Is
is
it
the
because it is at the same height, sir?
same height? Same height? Oh. Okay, so I think I understand your answer. It's actually if you are at this point, so means that there is another point on the same height as C. Okay, there is another point that is the same height as C. So if I from this point here, if I extend the line, so this is the another point that has the same height as C. Okay, so let's say I put here as point D. So point D and point C is actually the same height. Okay, the same height. So the same height means the same velocity. Okay, the same height means the same velocity. So, but then we have a different time. Okay, the same height but different location. So we'll have a different in time. The velocity, the magnitude is the same. So that's why here you have 0.63 and 1.14. So you have a curve like this. So the point D is for 0.63 and point C is 1.14 seconds. So this is the implication of the times that I mentioned previously. Okay, so if you notice that when the point pass the maximum height, okay, when the point pass the maximum height, you need to choose the highest time lah. Okay, the highest time. So if the point is less than the maximum height, okay, less than the maximum height, then you choose the lowest time lah. Okay, so this is based on the curve that I showed to all of you on the displacement and time relationship. Okay, so now you know that at point C, the time here is 1.14 second. Okay, so you have the x-axis equation, which means that as x minus s naught x is equal to uxt. So this is the x-axis equation because we want to determine the horizontal distance. Horizontal distance is based on x-axis. Okay, so Sx is we don't know d, and S not x is here is actually 0 is equal to uxt ux. So ux is 10 cos 60, 10 cos 60 time with the time here. So the time here is 1.14 second. So then you will get the distance. Okay. So based on the books, the answer is 5.7 meter. So any questions so far? Ada soalan tak? Again, jika if you have any question, you may ask directly. Okay, I give you time to think on this question A first. So if you have any question, you can ask. Okay, so then we go on question D. So I think I need an extra space. All right, so we go on question D. So now, question B. So now question B is Hmax. So the question asks Hmax is along Y. So if it's along Y, so you need to use equation along Y. Okay, because Hmax is along Y. So equation along Y is equation along Y. So let me copy this one. Right, so this is the equation along Y. All right, so you have here is since it's along Y, so you have Uy is equal to 10 sine 60. You have S naught Y is equal to 1.5. And then you have what? Okay, so this is for the initial point A. So now, since question B asks you maximum height, so maximum height at point B. So now, point B will become your endpoint. Okay, so this is the initial point. Initial point. So point B is the end point. So since it's a maximum height, so you know Vy at point B should be equal to 0. So maximum height, the change in direction. So Vy is equal to 0. So then at the maximum height, you have Sy. So Sy equal to 1.5, 5 meter. 5 meter. Okay, so I think this is the information. What else do you need for maximum height? All right, so do you still need the time at point B to determine the maximum height? Anyone?
No, sir.
Why?
Because we can use equation 2. No
Oh
time
yes,
need.
yes, correct. We can use equation number 2 because we don't need the time. Okay, we have the equation of Sy and S naught Y, and then Ay we know because it's a constant, and Uy squared we know Vy squared is 0, so you can use this equation. Okay. All right, so actually I do it wrong here. Sy we don't know because the given here, this 5 meter is for point C. Point B we don't know. So Sy is equal to Hmax. All right, so this one is the correct one. Okay, Sy for point B is Hmax. So 5 meter is for point C. All right, so we just substitute into this equation number 2. So Vy squared equal to Uy squared plus 2Ay Sy minus S naught Y. So Vy squared is 0. Uy squared is 10 sine 60 squared plus with 2. So Ay negative 9.81. So Sy is hash max. Then minus with S naught Y 1.5. Okay, 1.1.5. And then if you solve this one, you will get your hash max value, which is hash max is equal to this is based on this books. Okay, you can check either the value is correct or not. Okay, hash max is 5.32 meter. Okay, so I think for the X and Y analysis, usually the projectile, you need to understand the equation. So when the question asks you, please determine something like horizontal distance. So you know horizontal distance is along x-axis. So based on the equation on x-axis, you refer which parameter that you don't know and which parameter that you can relate to y-axis. Okay, if you can relate usually the time, usually we need to determine the time. Okay, and one of the important thing here is when you get the time here, you will get uh, two times. Okay, t1 and t2. So which time that you need to use. So usually for the projectile is just like that. Okay, it's play around with this kind of equation. Okay, so I think that's it for example 3.1. So I want to go with this example 3.2. You may notice that on this example, point A starting above point B. Okay, point A starting above point B. So this is when we refer back to the previous slide on the implication of the time, you may notice that if you have the information like this, the question like this, you may notice when you calculate the time, you will get one positive time and one negative time. So you need to choose the positive one lah. Okay. So a projectile is released from point A with velocity as shown. So you have a velocity 6 meter per second and determine the horizontal distance. So horizontal distance is equal to Sx minus S naught x is equal to Uxt. Okay, Uxt. So given is just the velocity and the height or the difference, the height difference, which is on a y. Okay, so you know the ux, so ux equal to vx is equal to 6 cos 15 and uy is equal to 6 sine 15. Okay, so for uy you have a negative. Okay, why? If you resolve this 6 to y-axis, it will directed downwards. Okay, so uy, that's why here you have negative value. Okay, so please remember, follow the positive direction. X-axis to the right, y-axis upward. So this is a positive direction. Okay, so you notice here Vy is 0, Ay is constant, and Sy. Sy is negative 3. Why? Because point B is lower than point A. Okay, so Sy is negative 3. Okay, if point B is above point A, then positive. And point B is below than the reference point, and then you need to put negative. Okay, so S not Y. So since we say that this is our reference point, so we just put S not Y equal to SAY equal to 0. Okay. Okay, and with unknown time. Okay, from A to B, we don't know what is the time. So we just put just unknown. All right, so since here you don't have the time in order to solve for this horizontal distance, okay, means that you need to use the equation number 3 of y-axis. Okay, so you just substitute all the information that you have here into this equation, then you will get the time, two time, negative and positive. So you need to choose the positive times lah, because it's in front. Point B is in front of point A, so it's a positive time. Okay, so after you obtain the time, you just substitute into this equation. Okay, so then you will able to get the horizontal distance. So any question? Ada soalan ke untuk example ni? Okay, here. Right, so this is examples 3.4. Okay, so you have a civilian ship, okay, detects a spy plane at an altitude of 6,000 meter or 6 kilometer with a constant velocity of 900 kilometer per hour. Alright, so this plane here is moving with constant velocity. Alright, so when this is a constant velocity, the acceleration will be 0. Okay. The ship launched a missile with an initial velocity of 540 meter per second. The instant the plane passes the vertical line AB, okay, means that this ship launch the missile when at the instant when at this line AB. Okay, when the plane at this line, then the ship launch the missile. Okay, so the unit determines the angle theta and the time required for the missile to hit the planes. Okay, so you need to determine the angle and then you need to determine the time required. Okay, for the missile to hit the plane. Both the ship and the plane lies on the same plane. Means that it's on the same on the SY axis lah, 2D, two-dimensional analysis. Okay, so what the information that we know? So we can know that the horizontal distance between A and C, so the horizontal distance between A and C and B and C should be the same. Okay, the horizontal distance should be the same. So this is the relationship that you can get lah. Okay, between between the ship and the plane. So the horizontal distance should be the same. Okay, okay, so the time taken since they are on the same line, okay, the same line of B and A. Okay, so you have the line here. Okay, the another relationship that you can obtain is the time. So since what we can say on the same lines, okay, on this line AB, so the time taken for the plane to reach this point C and the time taken for the missile to reach this C should be the same. Okay, this is one more relationship that you can obtain. Okay, so horizontal component should be the same, the distance, and then uh, the time for the plane and the missile to point C will be the same. Okay, so A to C is equal to P to C, horizontal distance. Okay, and then time A to C is equal to time B to C. So this is time. So this is the relationship on how the missile can hit the plane. Okay, so let me copy the equation first. This one is for y, this one is for x. Okay. So now you have the equation. So horizontal distance. Okay, let's we list all the information that we have. Okay. So for the ship, okay, for ship, okay, ship, u y is equal to y is 540 sine theta, and then ux is equal to 540 cos theta. So let's say here I put as usx, usy for ship. And then for plane, I have a upy, and then for the plane, upy, upx. So we just only have upx, which means that 900 kilometer per hour. So for this plane, we have only one axis, x axis only. So no direction on y for the velocity. So but then it provide you the 900 kilometer per hour. So you need to make it, the unit is consistent. So 900. Okay, so you can simplify this, change to the unit to meter per second. So you have 900 kilometer per hour. So you need to time with hour. 1 hour is equal to 3,600 seconds time with meter, 1,000 meter per 1 kilometer. Okay, so you can cancel out this hour, kilometer and kilometer. You will get 900 time with 1,000 over 3,600. So this is how you change the unit from kilometer per hour to meter per second. Okay, then you get 250 meter per second. Okay, so UPX is 200 meter per second. So this is the initial velocity of the plane. Okay, initial velocity of the plane. So since we know that the horizontal distance is the same, so we will use this equation Sx and S naught x. So what we can say here for the shape, S naught x is equal to 0 because it's on the reference point. Okay, so S naught SPX also 0. Okay, because it lies on the same line. Okay, it lies on the same line. So along x-axis, the S naught x as say the initial displacement as S naught x. So here is SP naught x. So naught is to represent the initial velocity. SP naught x. So this is initial velocity for plane. This is initial displacement for plane, and this is initial displacement for shape. So you have here is Sx minus S naught x. Okay, for shape, Sx SPX minus S naught for shape is Sx minus S naught x equal to U Sx time with t. So Ss x is unknown, minus 0, 540 cos theta time with t. So this is the equation of shape. Okay, of the shape of the missile of the ship. So first equation, and then you have the horizontal distance for the plane. So SPX minus SP naught x equal to UPXT. Okay, so SPX is unknown, so SPX minus 0 equal to UPX, so 250 T. Okay, so this is your second equation. Okay, second equation. Okay, so the horizontal distance from A to C from A to C here is SSX. So from B to C is SPX. So it's actually AC equal to BC. So SSX is equal to SPX. So means that final displacement along X for shape, final displacement along X for plane. So you can equate this equation. So equation 1 and equation 2, you equate both equation, which is 540 cos theta t equal to 250 t. Okay, because horizontal distance is the same. Okay, from point A to C and B to C. So you can cancel out this t, and then you will get cos theta is equal to 250 over 540, and theta is equal to cos inverse 250 over 540. Then you will get your theta. Okay, Alright, so then what you need to determine is the time required for the missile to hit the plane. So you need the information of the times. Okay, so the time required for the missile to hit the plane. So the time B to C and A to C is the same. Okay, so you have here is UY for this worksheet. Okay, you have UY is equal to 540 sine theta. Okay, and then you have here is Vy is unknown, and then you have Ay is equal to negative 9.81. All right, and then you have S naught Y. So S naught Y is 0. Okay, and then you have given here the the SY from A to C, which is 6,000 meter. So a reference point here is A, the end point here is C. So you just put positive 6,000 meter. So the time is unknown. Okay, so you need to know what would be this time. Okay, all right. So from here we have here is since we know uy ay s naught y and sy, then we can use the equation of this one, sy s naught y uy and ay. So we just leave the unknown t. Okay, so sy minus s naught y equal to uyt plus half ay t squared. So sy is 6,000 minus 0. Uy is, so from the books, what would be the theta here? Theta 62.4. Okay, so 540 sine 62.4 plus with half negative 9.81 e squared. So here you have t. Okay, so you can refer to this example. The answer is t equal to 14.78 second, and t2 you have 82.78 second. Okay, you have two time here. Okay, you have two time here. What is the time that you need to choose? Okay, like I mentioned, if the time is past the maximum height, then you choose the highest time. If the time is less than the maximum height, then you choose the lowest time. So for this case, if we see that this is the projectile, okay, the projectile still not reach the maximum height. Okay, we don't know what would be the distance, the maximum height. So what we can say here, this is the initial point, C. Sorry, this is the point where it's less than maximum height. So we choose the time, the smallest time, which is 14.78 second. So since here the reference point is below the point C, so that's why you obtained both time is positive. So you need to choose which time is smallest time. Okay, because it's not reached yet the maximum height. Okay, after the maximum height, you choose the maximum time, the highest time. Okay, so for this kind of example, if you have additional information, let's say you want to use other equation, make sure you have enough information. Okay, make sure you have enough information to use other equation. Okay, it will you will get the same, you will get the same answer. Okay, any questions so far? Ada soalan ke? Before we move to this exercise.
No, sir.
Yang lain ada soalan? Any question?
No, sir.
No, eh? So we go on one exercise. After that, we will end this class lah. So we are already at 12, almost 12:50. So we just do this one exercise, then we will end this class. Alright, so we have here a ball is thrown with initial velocity 16 meter per second as shown. So determine horizontal distance sx1, horizontal distance sx2, and then the maximum height. Alright, so let me copy the equation first. Alright, so when we talk about the horizontal distance, so this should be the equation. So sx minus s naught x equal to u at t. So if you want to use this equation, you need to have the time. Okay, you need to have the time. But for this exercise, you don't have the time. So it means that you need to determine what would be the time. Okay, so let's list all the information that you have. The starting point is A, initial. Okay, so uy equal to ua is equal to 6 uay 16 16. Okay, 16 sine 60 positive meter per second, and then ux equal to uax equal to 16 cos 60 meter per second. Okay, then you have s naught y is equal to 0, s naught x equal to 0 also. Okay, so the end point here, you can choose either B or D. So I choose B final. So Vy or Vby equal unknown, and then the Sy or equal to Sby is equal to 3 meter. Okay, so you may notice that for B and D, the height here is the same. Okay, on the same level, 3 meter. So that's why you can relate in terms of its time. Okay, because the height is the same, so you can relate it in terms of its time. Okay, so what else do you have? That is it. So you can use this equation, y first, in order to get what would be the time between A and B. So you just substitute into this equation. Then sy is 3 minus s naught y 0 equal to uy 16 sine 60 e. Okay, plus with half ay is negative 9.81 times with t squared. So you substitute into this equation, then you will get 3 equal to 16 sine 60 is 13.860 minus 4.905 t squared. So you just do the rearrangement, 4.905 t squared minus 13.860 plus with 3 equal to 0. Okay, so then the time here is T1 equal to 2.589 and T2 equal to 0.236. Okay, by referring to this height 3 meter from the datum or from the reference point A, you obtain 2 times 0.236 and 2.589. Okay, with this height, these two time here. Okay, so we have Hmax here. So you know that the lowest time will be time A to B. The highest time will be time A to D. Okay, so then you can determine what would be your Sx1, what would be your Sx2. Okay, so for Sx1, so Sx1 minus S naught x is equal to Uxt. So this one is for point B. So Sx1 is unknown, S naught x is 0, Uxt is 16 cos 60, time with the time here is 0.236. Okay, then you get your Sx1. Okay, and then you go for point D. So for point D, Sx2 minus S naught x equal to Uxt. So Ss2 is unknown, 0, 16 cos 60, and time with the time here, 2.589. Okay, then you get Sx2 in terms of meter. Okay, then Hmax, you need to determine Hmax. So Hmax at point C, Hmax. Okay, so Vcy equal to 0. Okay, so in order to get the Hmax, so okay, you have Vy squared equal to Uy squared plus 2a plus 2ay Sy minus S naught y. Okay, so this Sy is actually your Hmax. Okay, your S naught y is 0. Okay, so Vy squared 0, Uy squared is 16 sine 60 squared plus with 2 time with negative 9.81 time with Hmax minus 0. Then you will get your Hmax in terms of meter. Okay, so that's it for this exercise. So we will continue on the next class for other exercises. Okay, example and also other exercises also. Okay, so far any question? Ada soalan ke sebelum kita tamatkan kelas?
No, sir. Doctor,
Yes.
to find Hmax, the gravity is still negative, sir.
Yeah, negative because G always downward. But Ay ni kita consider sebagai G. So G direction dia sentiasa downwards lah, vertically downwards. So negative lah because we assume outward positive for Y and to the right is positive for X.
Okay, thank you, Doctor.
Okay, ada soalan lagi? Any question? So okay, jika tak ada soalan, if you don't have any question, so I think that's all for today. Thank you for your attention, and for those who not yet scan your attendance, please do so, and for the rest, Assalamualaikum and have a good day.
Thank you, sir.
Thank you, sir.
Thank you, Doctor.
Doctor.
Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.